Hi, my name is Elijah Hobbs. This lab was about experimenting with charged pieces of tape. In a previous lab, we created charged pieces of tape and experimented with how they interacted with various objects. However, in this lab, we are creating a simulation of our previous experiment by modeling the tapes as a collection of point charges, rather than just one point charge like we did last time. The main physics principle we will be using in this lab is Coulomb's law. Coulomb's law describes how forces apply between various charged objects. This allows us to describe the way the objects in this experiment will attract or repel each other. Additionally, we are using the principle of gravity to describe how the Earth will apply force onto the piece of tape. We can use these principles to model the main result of the lab, which was to cause one charged piece of tape to float using another piece of charged tape, as shown by the simulation I created for the lab. Specifically, we will be using a combination of gravity and Coulomb's law to describe how one piece of tape is able to make another piece of tape float. To do this, we are going to assume that the pieces of tape have the same amount of charge evenly distributed across their length, so that we can properly place point charges across the length of the tapes. Additionally, we will need to treat the top tape as a point mass in order to properly calculate the force of gravity on it. Now that our assumptions are in place, we can begin to model our experiment in VPython. In order to start modeling stuff in VPython, we need to clearly set up the system and initial conditions. The system is the top piece of tape, and the surroundings are the bottom piece of tape in the Earth. Initially, the top tape is being pulled down by the Earth, with the bottom tape far enough away to not affect it. Then, the bottom tape is brought towards the top tape, till the top tape begins to float, which is what we are trying to model. For my code, I mainly edited the starter code, so I'll go through and show all the parts I changed. First, I plugged in my mass and charge values. Then, I copied my function for an electric field. Next, I corrected the distance between my tapes. Then, I added the scaling for my electric field and electric force arrows. Next, I added in my code to calculate the electric force and to create the axis for the electric field. Then, I added the axes for the electric force and gravitational force arrows to create my final model. The final model features many green arrows showing the individual electric fields created at each point charge and the overall electric force and gravitational force. Now considering that what-if question, if I had modeled the tapes as point charges like I did in the last lab, I would have gotten an electric force of 2.00931 times 10 to the power of negative 3, which is different from the value I got from my new model, which was 2.17558 times 10 to the negative 3. Turning to the y question, the two values I got for the electric force from my two models are similar, but still clearly different. I believe that my new value is more accurate because in reality, things do not exist as point charges, which is the assumption that I used for my original model. And while objects do not exist as perfectly distributed lines of point charges either, I believe that that assumption is much closer to reality than the assumption of point charges. The biggest source of error in my experiment was the fact that I did assume that the tapes had a uniform charge distribution. This was likely not the case, which means that the reality of my experiment would be different from my model. This could lead to the force having a different direction than perfectly vertical like my model assumes, which would make my model inaccurate. Overall, I think my new model was a big improvement in accuracy over my original model from Lab 1. It still makes some assumptions about charge distributions that will lead to error, but I believe that it is much better than my original model.